Hi guys, today we're going to be doing arithmetic series for IB HLAA maths. So arithmetic series is one of the types of series we'll be doing in HLAA. So a series essentially is just an order arrangement of numbers which has a specific pattern to it. So specifically for an arithmetic series, terms in the series, which just refers to the numbers, each number is its own term. Terms in the series have a common difference, d, which we refer to as d. So we can see for this order of numbers, the d is 4. And the thing that makes an arithmetic series is that the common difference is the same for every single term of the series. So as we can see here, every single time the numbers increase by 4. But for example, if we had another series where it first term was 1, then it became 2, then 4, then 8, then 16, then the difference between consecutive terms is changing. Hence, this is not an arithmetic series. Now, an arithmetic series doesn't necessarily have to increase. It can also go down. It can also be something like 6, 4, 2, 0, minus 2, minus 4. And in that case, the common difference, which we refer to as d, as mentioned earlier, is just going to be a negative number, which here is minus 2. So what is some common notation that we use when talking about an arithmetic series? Well, so in order to refer to a specific term in the series, we use the letter u, and in subscript we write the term number we're referring to. So this number can be anything. Let's just write n, which denotes the term number. So for example, u1 is the first term. So for the first series that we did here, u1 is equal to 0. In this series here, u1 is equal to 6. u3 would be the third term, so in this case u3 is equal to 8, and here u3 is equal to 2. So u is just used to refer to term. u1, which is the first term, can sometimes also be written as a, but this usually doesn't happen in the IB. D refers to the common difference. Which is just the change of value between terms in an arithmetic series. So in the first one that we did here, the common difference is 4, while in the second one, the common difference is minus 2. It doesn't necessarily have to be an integer. It could also be a fraction. What's important is that the common difference remains the same throughout the series. Otherwise, it's not an arithmetic series. So the un, which we talked about here, is referred to as the nth term. Sorry about that. So as we were talking about the nth term, which I will explain now. So let's say in this series here, you wanted to find the 100th term of the series. Now it'll take a really long time. If we went 2, 4, 6, 8, 10, then it would be 12, 14, 16, 18. So in order to help us to do this, we use the nth term formula. So this formula is in your IB data booklet, so you won't have to memorize it. So it goes un, which is the nth term, is equal to u1, which is the first term, plus n minus 1 d. As we discussed before, u1 is the first term, d is the common difference, and n here will refer to the term number you're trying to find. So if you want to find the third term, you'd sub in n is equal to 3. There's also many instances in the IB where you'll need to find the sum of an arithmetic series. So the sum of a series is just the sum of all terms up till a certain point in the arithmetic series. So for example, S3, S is used to denote the sum. S3 is the sum of the first three terms of the series. So it would be U1 plus U2 plus U3. We also have two formulas for this in your data booklet, so you don't have to memorize it. Sn is equal to n by 2 2u1 plus n minus 1 d, which is also equal to by 2 u1 plus un. So these two formulas can actually just be used in all contexts. They both give you the same result. You can actually derive both of them from each other. So if you observe this part of the second equation, u1 plus un, judging from our nth term formula which we have for un, we can sub in u1 plus un is equal to u1 plus n minus 1 d. So we can sub this in here, u1 plus n minus 1 d. So that equals to 2u1 plus n minus 1 d, which is the exact same answer that we have in the other equation here. Sorry, the exact same expression that we have in the other equation there. So they do equal the same thing. And let me just explain why this formula works. So let's look at this series, which goes from 1 all the way to 10. So if we wanted to find the sum ordinarily of this, we'd have to take a really long step. 1 plus 2 plus 3 plus 4 plus 5. And while maybe for a small series like this we can do it, sometimes in the IB they might ask you the sum of 300 terms, and that'll take a very long time to work out. So if you notice, if we add the first term and the last term, what does it give us? 1 plus 10 is equal to 11. If we add the second term and the second term from last, 2 plus 9, it also gives us 11. We can pair up each and every single one of these terms. So 3 plus 8 is equal to 11, 4 plus 7 is equal to 11, 5 plus 6 is equal to 11. Now we can simplify the equation further, which just gives us 11, because 1 plus 10 is 11, plus 11 plus 11 plus 11 plus 11. Because we know that we have to add 11 5 times, because we got all these pairs here. This can further be simplified into 5 times 11, because we have 11 5 times. If we look at it even further, it can be written as 10 by 2, because 10 divided by 2 is 5, times 1 plus 10. So we know that the number of terms in this sequence is 10, because there's 1, 2, 3, so on, all the way till 10. So that's the n here. 1 is the first term of the sequence, u1. 10 is the last term of the sequence, un. So we still get the same formula, where n by 2 times u1 plus un. That's why this sum formula works. Sometimes in some questions you might just be given the sum expression and they might ask you to find the arithmetic series un. So let me explain how that works. So the sum of n terms we know is the sum of u1 plus u2 plus u3 all the way up till we get to un. So for example, what is the s of 1 equal to? Equals to just u1. So you can actually find terms in a sequence just by using the sum formula. So for example, let's say we want to find u4, the fourth term of a sequence, but we only have the sum formula, Sn, right? That means that we can do the sum of 4 terms in a sequence minus the sum of the 3 terms in a sequence, because that is just equal to u1 plus u2, 2 plus u3 plus u4 minus u1 plus u2 plus u3. So if we subtract that, we get u4. Essentially, you can generalize this. Un is equal to s of n minus Sn minus 1. Now this formula is not in your data booklet, so you don't need to memorize it because it should be quite intuitive, but it's a very helpful formula to know for especially some higher level questions. So that's it in arithmetic sequences and series. Follow along, and I've also posted a video on solving some exam questions related to arithmetic sequences and series. Thank you.